Hey guys, welcome back to Computational Biology with Python. In this lecture, we're going to be learning about making choices. This is not the life choices you've made. This is Python choices. I look at that, I put that intro video at the beginning of the quarter for this class, and I show the amount of money that computational biologists are making in startup companies in biotech, and then I wonder about my choices because teachers, college professors don't get paid that much. I'm just joking. I love teaching y'all, right? It's altruistic. Okay, so without getting too much into it, it seems very bright. I guess I'll use the low setting. Without getting too much into it, let's jump right on in. I guess I don't look as washed out. All right. So first things first, let's get into our my files. Perfect. I'm gonna make a Python document. I'm gonna save it right off the get-go, and I am going to call it making choices and save it. Okay, so choices, it's kind of a weird title for a video, right? Making choices. It's kind of like if-then statements, right? So what if we want a script to decide something, right? Taking in data or some sort of input to actually decide. So that's kind of where making choices, it's kind of a catch-all name for if-then statements and things like that. So first thing I'm going to do is I'm going to say number equals 37. So we're defining a variable num, and that's equal to 37. So if num is greater than 100, then we'll print, there we go, greater in our printout. But else, so any other option, print not greater. And then we're going to print done to say that, okay, this function is done. So right now we tell it num is 37. So that's independent of our if then or if else statement. So we say, okay, if the number, whatever saved in num, is greater than 100, print greater. If it's not, else, print not greater. So it's not greater, and then we hit done, right? So the second line, the else statement tells Python that we want to make a choice. If it follows that the first part is true, then it ignores the second part. If this part is not true, then it prints the second part. So this is kind of shown. Ooh, it's tiny. Make it bigger. All right. So we have our condition, and then we have our number, and it says number is greater than 100. If it's true, print greater. If it's false, print not greater, and then they both go to print done. So it's kind of a way to visualize what's going on. Okay, so let's try something else. Num equals 53. Print before conditional let's give me two of those. There we go. Okay. If num greater than 100, print num is greater than 100. Print after conditional. Okay. So one thing to note, especially for you R people, the people that took my R class, whenever you have an if statement, you have to indent the next line. Python, super anal about indents. So if you don't indent, you're gonna have a bad time. R doesn't matter. This does matter. Okay. Invalid syntax. I forgot the semicolon. And let's play that. There we go. All right. So what I want to show here, so a number is 53, print before conditional. If the number is greater than 100, print num is greater than 100. But since our number was not greater than 100, it just assumes it's false, right? So what this is showing is that you don't have to have an else statement. So you can see here, we don't have else, we just have a nothing, right? So so we can even get rid of this if we wanted to, and run it, and it still runs with no else. But I want to put that, what am I doing? Put that back in, undo, there it is. Yeah, so you don't have to have an else statement. You do have to have the if part, but you don't have to have the else statement for an if else thing. So you can also do an else if. So we have an else here, but you can do an else if, which allows you to do more than just one. So else is you have one condition. So you say if this happens, you have two conditions. If this happens, do this. If the other thing happens, do this. That's it. But what if you have three things that you want to happen? So we'll do num equals -3 if num is greater than 0. Print type. Thank you. Print. That's why I said print. Print num is positive. And then we say elif num equals, so just like R, to say equals, you do a double equal sign, equals 0, print num, and then put this in, is 0. There we go. And then else, print num is negative. Okay, so now we have three conditions, right? So we have, all right, if the number is positive or greater than 0, we'll print that it's positive. If the number is 0, which is neither negative nor positive, we'll print is 0. And then if the number is not either of those two, if it's not positive and if it's not 0, it's got to be negative, right? Then we'll put is 0. Let's run this. -3 is negative. So I could change this number. So I can say, I'll change it to 0 and run it. 0 is 0. Negative 0. Negative 0 is 0. 0 is 0. And we'll put 14. 14 is positive. Okay, so our condition statement works great. Okay, so so we can also add conditional statements like and or. So it only will give us a positive or one of these conditions, like this print, if two conditions are true. So for example, if 1 is greater than 0 and -1 is less than or is greater than or equal to 0. This is supposed to be there. Then we want to print both parts are true. Else, print at least one part is false. So, as you can see here, we have two conditions. we said if 1 is greater than 0, that is true. And if -1 is greater than or equal to 0, that is not true. So this if relies on these two things both being true, right? If I change this to 1 is greater than 0, I'll keep hitting that, and I run it, both parts are true. Because 1 is greater than 0, greater than or equal to 0, and 1 is greater than 0. -1, however, is not. So that becomes a problem. But what if we did the same thing? So I'm just going to copy this, paste it right here. But what if we change this to or? And then we're going to get rid of this, and we're going to say at least one part is true. So if I say if 1 is greater than 0, or, all this requires, since I have or in here, is that one of the two are true for this to print at least one of these is true. There we go. If I said -1 and -1 and I ran it, nothing prints because I don't have an else. So if I did, I could do this and I could add to it else. I'm gonna put this down here and I'm gonna say both of these are false. Let's put something in there like that. So since both of these are false, I print both of these are false. If I do this, only one of the two has to be true because I said or. At least one of those are true. 11 minutes. All right, let's keep going. Let's look at checking our data. So we're going to import numpy, whatever you're going to call it again, which remember is our package that does really good with like numbers and things of that nature. And actually what we want to do here, let's save. We're going to save this. Saving complete. Okay. And then we're going to continue into our data folder. So you want to move into SWC, right? Software Carpentry, Python. Then you'll move into data. And then Python 3. And we'll call this one oops. So just change the untitled part. Don't change everything. And we'll call this one making choices 2. Okay. So now we're gonna do this. Import NumPy. We'll run that just so we have it imported. And we're going to do some stuff with our inflammation. Inflammation 0 is numpy.mx data axis equals 0. And we're saying max. Hold on a second. Okay. Let me run this real quick and see. Data is not defined. So we're gonna have to reload the data. So let me get the, what is this? Huh. So we have to run this line here first. Okay, so we loaded now our data here that we had done before, but since we exited and we're coming back in, at least I did when making this video, it wasn't liking it that I didn't have it loaded again. So I'm gonna run this. Data is not defined. I divided. So I gotta say data equals. Alright, let's try this. Now let's run this. There we go. Okay. Okay. So then max inflammation 20 equals numpy Emax data axis equals 0, and then we'll grab the 20th entry, and then we say if max inflammation zero is equal to 0 and max inflammation 20 is equal to 20, print suspicious looking maxima. All right. Okay. And max inflammation 20. Oh, I have to run? Wait. Max inflammation 20. Suspicious looking maxima. Okay, so what this is doing is it's looking at the inflammation scores, and it says, we wrote a little if-then statement. It says, okay, if the inflammation on day 0 is 0 and the inflammation on day 20 is 20, that's kind of weird, right? So it might be something where our data is messed up, where we're reading the wrong column, like we're reading the day number as opposed to the inflammation data. So this looks at those files and says, okay, what is day 0, what is day 20 if day 0 equals 0 and max inflammation, so day 20 equals 20, that's suspicious. So let's also do elif numpy sum numpy the min data axis equals 0 print minima add up to 0. What's going on here? What is going on? Why is that a problem? I might have to have it in the same code chunk here. So if we do the sum, this command here, what this command is doing is says, all right, let's take the sum of the min and determine if it's 0. Remember, this is the inflammation study. And so if we looked at we can even pull up our graphs right here from previously, and we see that there's the inflammation max is at 20, etc. And this is the min, so the minimum inflammation, right? So what the command here is saying, if the sum over the entire week is 0 for the inflammation, so it'd just be a straight line across here, then we say minima adds up to 0. What that would mean is that there's a healthy person in our study, right? They never had any inflation. It never went up or down or anything. It just stayed at 0. So this command is saying, look at the data. If it never goes up, like this one went up to 20, right? If it never goes up, then a healthy person must be in the study, or it's a control group or something. And it is stuck at, it alerts us that it's stuck at 0. Then we can do else. We can say print seems okay. And so when we run this, the reason that nothing comes up is because there's no healthy people in our study. We could add people, it'd be a lot of work to add people, but we're not going to do that. Okay, so let's see. Now, let's do this. Let's do data equals. Actually, we are going to do the healthy person thing. Load txt fname equals. We're going to do inflammation 03 dot csv. And we're going to say our delimiter, or what separates our data, is going to equal a comma. Ever since I switched to this new keyboard, I got this, fancy, makes different colors, light up keyboard, and my typing is already bad. I'm not trying to make total excuses, but it's so much worse. Okay. So see, as I said, max inflammation 0 equals numpy amax data axis equals 0, and then we want the first. Remember, 0 for some reason is the first measurement because we count starting with 0 in Python. Max inflammation 20 equals numpy amax data axis equals 0, and then we're going to do the 20th measurement. So now we're going to write this command again. If max inflammation of 0 equals 0 and the max inflammation 20 equals 20, then we're going to print suspicious looking maxima. So that's again a command to tell if we're not looking at inflammation data, we're just looking at like the participant number or the day number or whatever. Elif numpy sum numpy amin data axis equals 0. If that equals 0, then we're going to print minima add up to 0. This is where we had, and we can even add this. Let's do something weird. Minima add up to 0. Healthy participant alert. Whatever you want here. Alright. And then I'm going to say else. Print. Seems okay. Alright. That's a lot of typing. Let's see if it works with. Hey, there we go. Alright, so in this data, so what's different? You might be like, why does it say this now? Well, so we took a different data sheet, right? So we took the inflammation 03. So we over here, if you look at your files, you have 1, 2, 3, 4, 5. We have 12 participants or inflammation spreadsheets. Before up here, we used 0, 1, and we found that there was a suspicious looking maxima, but there was no zero sums, right? But in data set number 3, we run it and we say the minima adds up to 0. There's a healthy participant here, which is good. So we figured out how to use the condition and make it make sense. Oh my gosh, 26 minutes. Sorry, this video is long, but I think we're done. We're done so far with these conditionals. Apologies for the long video. I tried to stick into that range of 20 minutes, and this one got away from me. I was having so much fun. Right. All right, so that's conditionals, right? So we can write these things. We can have our Python script make choices for us. Choices in the sense of we tell it what the choices are, but like it can do if-thens, either-or type stuff where if one thing with your data is, you can tell it, look at this data without seeing it beforehand, evaluate some condition like, does this equal 0? If it does, do one thing. If it doesn't, do another thing, which is really kind of the heart of I guess it's really the heart of machine learning, but really the heart of programming language, right, is conditionals. Like if you play video games or if you do even any sort of web page or whatever, it's all conditional stuff. Like, okay, if you're on this page, display this. If you click this button, go to this page. It's all if-thens, ors, and things like that. So that is it for our basic Python stuff. We're going to continue on with our next video. We actually made it all the way through in our 30-minute long video here through making choices. So we'll look a little bit at functions in the next video. So if you're on YouTube, hit like, hit subscribe. I appreciate you viewing my videos. I hope you're learning something, and I will catch you in the next video.